All right, I'm going to cover the space news as of March 6, 2021. This is covering about the last month since our last meeting. The main theme here today is Mars, because there's 3 missions to Mars. This picture of Mars, in fact, was taken from the Chinese Tianwen-1 mission shortly before it arrived and was inserted into orbit. So it turns out that the old movies where the Martians came to attack us is kind of went the other way. We're definitely going the other direction toward Mars. So there are 3 missions that have arrived there: United Arab Emirates, China, and the United States. Right now, we're the only ones that did a landing. United Arab Emirates probe essentially is in orbiter. It's a satellite. It's going to be monitoring the weather and so on. I'm not going to spend too much time on that. I covered it back in last August. China, right now, is only just orbiting, and I'll talk more about that in future meetings when they actually have their lander. We'll focus a lot on the U.S. Mars landing. As a reminder, the reason they all 3 arrived all there at about the same time was there's windows that come every 26 months, kind of a favorable alignment of planets, where going from Earth orbit to the Mars orbit, there are times when you can do a fairly minimal energy coasting run to switch orbits here. And so, for instance, the planets in this case are going counterclockwise in this view around the sun. From this point on the top of the Earth orbit here, we launch, and that meets up with Mars, which also meets it at the same time. So that only happens every 26 months, and that's why all 3 of these missions went at about the same time. These trips all take about 200 days. They went about 300 million miles. So the UAE mission, as I mentioned, is mainly focusing on weather and monitoring the atmosphere and analyzing the atmosphere. In fact, actually, a lot of people think there's going to be some pretty good science coming out of this. This was done in collaboration with some American universities. They really have a fairly impressive space program for a small country. They have a program called Mars 2117. They're trying to build a world-class space sector, and they appear to be on their way to do it. It's amazing because they're so small. They only have 9 million people, and actually only 1.4 million of those are actually citizens. The rest of them are contractors. China, we'll really talk more about that in the future. As I said, they're putting a rover on Mars as well, but they're not going to get there until May or June. Right now, they're just sitting in elliptical orbit. The lander, when it goes, will be landing at a place called Utopia Planitia. There is a large water ice reservoir believed to be under this, that this has been determined from orbit before. So they're going to analyze the soil and rocks and look at the internal structure. Like the American lander, they have subsurface radar looking down for things like buried ice and the geology. And if they do land success, they will be only the 3rd country to do the soft landing on Mars, and only the 2nd to, in fact, drive a rover. So let's get on to the NASA Mars mission. This is a big one. It went on an Atlas V rocket. It is the most advanced robotic explorer we have yet. It's based on a Curiosity, which is a rover that arrived there in 2012. And interestingly, it is still active, and that's because it was so reliable. They reused about 90% of the parts from the Curiosity rover into Perseverance, which is the new one. But that other 10% made quite a few advances. To put things in perspective here, NASA has landed on Mars 9 out of 10 tries. So they have a very high success rate on this. They know what they're doing. Only one other country has even managed to land on Mars successfully. Plenty have landed unsuccessfully, too fast. They landed in 1971, so was that 50 years ago? And that they had a successful landing, but the lander only lasted 2 minutes. So really, NASA is clearly the leader in this area. So the Mars rover itself, it's about a ton, about the size of a car. It is nuclear powered, just like Curiosity, or for that matter, like the Voyager probes. They have a plutonium-based heat source that just decays about 2% a year. These things have the advantage of being very reliable. I mean, you're pretty much just generating heat. It's not a reactor. It's just generating heat. It decays about 2% a year. The prime mission of this thing is to spend at least 3 years in the Jezero crater. This is an ancient lake bed and a river delta. The crater itself is about 30 miles wide. The goal is to search for ancient life. That is, maybe fossil remains or chemical remains that indicate the possible presence of life in the past. And they have a lot of instruments for doing that. Of course, along the way, they're also, doing a lot of things that are going to help for future Mars settlement, such as detecting the presence of water. They will be drilling for samples, and they will be caching. They're going to stick them. I'll show you in the next slide. They'll be sticking them, basically kind of storing them on the rover temporarily, but they're actually going to cache them. They're just going to leave little caches of these samples around on the surface of Mars for another mission to pick up, maybe in 2031. They'll be doing weather and monitoring, as well as their testing for ancient life. Also, things like testing spacesuit samples right here on the front. In fact, what they do is they can actually blast that with a laser or something to test it. And they do all kinds of tests associated with the spacesuit samples. One big change is this thing is doing autonomous driving. And that may not sound like much, but think about the fact that, it's a 20-minute round trip communication delay. So if someone wants to say, watch out, there's a boulder that took 10 minutes for the signal to get there, 10 minutes to go back, you can't drive very fast at that rate. And that really slowed down Curiosity. They figure just having autonomous driving where they can navigate on their own while they're driving, that speeds them up by a factor of about 5. The actual top speed of the thing is 0.01 miles per hour. So they got us maybe 53 feet per hour, but they can keep that up. Whereas in the past, the rover Curiosity had to have a lot of stops, or had to stop and look around and think about it and wait for instructions. This is far superior. Some of the scientific instruments that are here. First of all, they have a lot of cameras. There's 22 cameras. They're everywhere, and a couple of microphones. So now you have you can actually hear what's going on there as well as seeing it. They have a fairly tall mast. And they have a zoomable camera. That's the first on Mars. They can see a housefly at 120 yards. They have a laser that can zap rocks. It's mounted on the same mast. And anything within about 23 feet, or maybe more, they can zap. And what they do is, in the process of vaporizing the rock sample, they measure the spectra with various instruments. And as a result, they can determine what is there. So this is really a fairly advanced form of determining the composition of the materials on the surface. And then, of course, they have the drills attached to the robot arm. It's about a 7-foot arm. And then they also have some of these other spectrometers attached to the robot arm as well. The sample handling carousel is here. So when the drill picks up a sample, it's about the size of a piece of chalk, for those who are old enough to know what a piece of chalk looks like. And then the robot arm would take that, it would insert it in the carousel here, and it'll actually get stored for a while underneath this thing, and then eventually get dropped off in a cache. Other things going on, the subsurface radar I'd already mentioned, they can go down about 33 feet looking for things like water or geological features. Again, all actually pretty useful for figuring out how to inhabit Mars. They're also doing an experiment for the first in situ resource use. They're going to try to take some of the atmosphere, which is almost all carbon dioxide, try to get some of that and simply just react it to free up some O2 as an experiment. The O2, of course, in the future would be used for rocket propellant or for humans to breathe. So that's actually a pretty important step, is to start thinking more about in situ resource use. Really, you're not going to have any space settlement until you have that. The landing, you're going from 12,000 miles per hour to 0 in what they call the 7 minutes of terror. You're starting off here. There's a cruise stage, which is what got you to Mars in the first place. They separate and they start their descent. The heat shield, of course, is getting very, 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 very hot during this period. Heats up about 2,400 degrees Fahrenheit. The parachute is deployed automatically based on looking at the terrain and figuring out when is the right time. This helped improve the accuracy of the landing quite a bit. So the parachute is deployed. Fairly shortly thereafter, the heat shield is dumped. And then radar and cameras are again matching the terrain against previously stored photos, so they can do their best to land in exactly the right spot. So based on that analysis, they decide when to finally separate from the parachute, drop off what's called the sky crane, and that has a powered descent. It has 4 rockets on it. And they lower it, and it's called a sky crane. And what happens is the sky crane then lowers the rover itself to the ground. This has a lot of advantages, such as not requiring landing legs of any significance, and also not having so much dust flying around on the landing site. And then when they literally cut the cables from the sky crane, and that sky crane flies off and crashes half a mile or so away from there. This is what it looked like. This is the artist's conception on the left here, showing you the sky crane, while it's powered during the descent phase. And the rover, the wheels had not yet been lowered into final position. On the right, I have an actual photo here. This was taken from the sky crane looking down onto the rover. You can see the 3 support cables, clearly here. The wheels in this case have already been deployed in the downward position. This other cable is what is for communications purposes. So for instance, this picture was taken from the sky crane and it was transmitted back down to the rover, so that we eventually could see it. So it's pretty impressive. And again, all this had to be autonomous because the whole thing has to happen way too fast. With that 11-minute transmission delay each way. So where did they land? Well, to give you perspective here, that little green dot in the center of this picture is where they landed. This is actually fairly rough terrain all around here. So they managed to pick out autonomously a good spot to land. Their target was a 4-mile wide landing zone, and they managed to get within that. In fact, they were only 1 mile from the center of that. And, there had to be some flexibility. So that was considered quite a success. They found a flat spot. It was only tilting 1.2 degrees. And there were boulders all around it within 35 meters. So this was quite an impressive landing. Shortly after they landed, they started taking panoramic photos, very high resolution, and they pasted them all together. This represents something like 140 pictures pasted together to form this. And you can find these things on the internet. You can see the details if you want to look in more depth. But these are the crater walls here in the distance. And shorter mounds are also available here. So anyway, what is the status here? Well, they managed to land in a flat spot. Then they sent back images and sound recordings already. This particular one is one of the live ones. This was taken from one of their cameras. It also happens to be the background in my Zoom session here. What they've been doing so far is mostly just activating equipment and testing it very, very carefully. It takes several weeks to really get all that done. There's a software update they had to go through to switch the software for doing the cruising to Mars to doing the roving. And that actually takes 4 days. Sounds like a lot for a software update. Worst at Microsoft by far. But they're being extremely careful. They're not even transmitting it. This was a pre-stored. It just needed to be very, very carefully tested stage-wise as it happens. And all the things that have to go on, you start up the instruments. For instance, they deployed wind sensors and that sort of thing. They had to establish communications. There's all the satellites that are around Mars right now are pretty much involved in relaying communications back from this. They have flexed the robot arm, so they know that works. They also took a test drive on March 4th. And in fact, what that looks like is this, where they went a short distance and went in a circle and came back. But the main thing is that proved that all the parts worked. The wheels could rotate, the power could be applied. So everything is really looking quite good. This is quite successful so far. Where are they going? Well, it's interesting to look at the picture at this scale. You can kind of clearly see here that there's a river and a delta and the crater here on the right-hand side. So they landed where there's a little white spot is over here on the right side of the thing. One of their goals is to spend a lot of time in this delta region, because the idea there is if there was ancient life, chances are pretty good. There was flowing water, there would have been sedimentary deposits at all different time periods. And with some luck, you'll find something. So they're going to spend a lot of time doing that. So they've mapped out several possible routes. They haven't picked exactly what they'll do yet. But they'll go past some little impact craters and eventually work their way. And depending on timing and success of the mission, they may really take a much longer trip. They eventually could, in fact, get out of the crater altogether. It just remains to be seen. Depends on what they discover and how the equipment holds up. If you want to know where the Perseverance rover is at any time, there's a website for that on the nasa.gov site. You can just do a Zoom search and ask where is Perseverance, and you'll see pretty quickly how to find this site. This is the exact link, but you don't have to write that down. Just do a Google search on where is Perseverance. Landed here. This was the original landing zone, and this, of course, this is that river delta where they'll be heading. And maybe they go up the river or whatever. Think of this as the Mississippi River Delta without water. The helicopter, I'll talk more about that in future news because they haven't launched it yet, and well, it'll be fresher news then. So we're going to skip over that. But it's a fairly interesting story in itself, and all new technology. None of this had been done. No rover has done anything like this before. Most people probably don't realize it, but there are in fact 11 missions on Mars right now. 6 of them are NASA. There's the 2 rovers we've talked about, Perseverance, the new one, and Curiosity, the old one it was based on. InSight landed in 2018. That's not a rover, that's just a lander. It was doing seismology studies, drilling. It tried to drill, it didn't get as far as they hoped. But drilling and getting temperatures and doing weather analysis and so on. And there's orbiters, satellites. So they have 3 of those. The European Space Agency also has 2 orbiters as well. So all these satellites are doing typically weather monitoring, analysis of the atmosphere, surveying the ground resources. They're doing all these things. And additionally, the ones from ESA and NASA are also acting as communications relay satellites to get the communications from the rover back. ESA, actually one of those missions is shared with Russia. So they're involved in one of those. India has had an orbiter up there since 2014. And of course, there's the new ones, the Arab Emirates and the Chinese mission, which will hopefully have a lander as well. Off to something different. There's an asteroid that just went by last night. I didn't hear if anybody got any good pictures or not. It's about 1,000 to 1,500 feet across. It's called Apophis. If it happened to hit the Earth, that'd be about 1,000 megatons of TNT in terms of its equivalent explosive force. Now that's nowhere near as bad as some of the other asteroids that might hit us. The one that killed the dinosaurs and 70% of all the species on Earth, that was 6 to 10 miles wide. So that's quite a bit bigger than this one. But obviously still this attracts a lot of interest because it's coming close. It passes the Earth about once a decade. It's not really expected to collide with us in the near future, meaning the next century or so. This particular time, it passed 44 times the Earth-Moon distance, so it's still quite a ways away. However, this one is especially interesting because it will pass within 19,000 miles in 2029. That's in the range of our existing geosynchronous satellites. The ones up there in geosynchronous orbits are at about 19,000 miles. So there could be some damage there. Or disruption of orbits. Now the astronomers are really interested in this one because this is still a chance to get a really close observation on another asteroid. No missions that I know of have been planned for this yet, but there's been a lot of talk about what to do about it. This is just to help you visualize what it would look like if this thing could just somehow settle nicely alongside New York City. Obviously, this would just be a huge crater if it actually hit. Some other news. The Space Launch Systems, that's been the kind of a long-term government-sponsored program to get a heavy lift capacity. It actually has been canceled out of the Europa mission. Europa is a moon of Jupiter. It has some fairly interesting reasons for going there. This picture shows you an idea of what it looks like. They were pursuing 2 parallel paths. The one path was with SLS. The other one was with a commercial heavy lift rocket, and that's just the code word for the Falcon 9 Heavy. That's the only one that's actually proven. They do want something that's proven for these missions. Now, if they had gone with SLS, they would have had to delay the launch in 2024, which is when it was planned. And there's several problems with SLS. One is that it has been falling behind schedule, been kind of disappointing for a long period of time. But even if it follows its development schedule, the problem is the Artemis moon program is assuming the use of the SLS, and there wouldn't be any SLS rockets available. Now, there are some impacts on the mission as a result. The trip will take longer. It'll take 5.5 years as opposed to 2.5 to 3 years to get there. The reason is that the Falcon 9 Heavy actually doesn't have as much power as the SLS did. This means it will take gravity assist. So they'll have to pass some planets and get kind of a boost from being pulled along by the planets. And that's why it would take longer to get there. The other thing that would be of interest to the Falcon 9 users, of course, is that they would have to use all the booster fuel. There wouldn't be any reuse involved in those boosters. They just need every ounce of propellant they can get to get the mission going. It turns out that about reusability as used in the Falcon 9 does come with a cost. You have to have about 30% of the fuel reserved before coming back to land, whether you're landing on the barge or coming back to a land-based launch pad. Either way, it takes fuel to accomplish all that, and that would just there wouldn't be enough fuel even to make it. So they have to use all of the fuel to the booster. It's kind of interesting. You go back to some previous state. Back in 2014, Charles Bolden, who was the head of the NASA at the time, he said that, well, Falcon 9 Heavy may someday come about, is on the drawing board, but SLS is real. Turned out he didn't quite get that right. Now for something totally different, a luxury space hotel. There's a company called the Orbital Assembly Corporation, and they've announced an ambitious plan for a luxury space hotel. They'll start building the actual hotel in 2026. Maybe it's available in 2027. Now, this thing is as pictured on the left. It's a 650-foot diameter wheel. They're going to rotate it so that they could get moon-level artificial gravity, about a sixth that of Earth. Their plan is to outfit it very much like a very expensive cruise ship. In other words, this is definitely going to be a luxury liner kind of a thing. Eventually holding up to 400 guests. They would build it in stages. They wouldn't have it being as big as that at first. There would be 24 habitation modules, and you can see them in this drawing kind of arranged around, around the structure. Each one of those is 65 by 40 feet, and they're imagining private airlocks. So they're kind of imagining people are just going to go out on spacewalks. So that remains to be seen. But anyway, that's the plan. So where are they now? Right now, they're really mainly producing slick marketing brochures. They're trying to raise money. So there's a big push to get the investment. At least they're doing the thing in stages so that the earlier than the 2026, they would build a 200-foot prototype in low Earth orbit. In fact, they would spin it faster and they'll build the thing in stages. Now, they're advertising as, obviously luxury view. The economics really will depend on Starship being ready. They're showing one here because they need to get the cost. They want to get a lot of people going up to a space station. They're going to have much lower costs than even now. But what they're selling is, besides the accommodations and the views, would also be experiences such as low gravity sports. Here they're envisioning something like a basketball. So anyway, they're out there looking for money. Their economics remain to be seen. I haven't seen many technical details. I got the impression right now it's more getting their name out there and starting to raise money. Another interesting thing is, reusability has been proven by SpaceX as being essential to getting costs down, in particular the boosters, but even the second stages, the fairings, all these things. Now, Rocket Lab early on, this is the one originally out of New Zealand, they had based their technology differently. Their claim to fame was the carbon fiber rockets and the 3D printed engines. And they thought that was their big technological edge. And at one point, the CEO said he would eat his hat if they ever moved toward making boosters reusable. Well, as time went on and they saw that SpaceX was doing well with it, they changed their mind, and now they're pursuing the same reusability. So he promised to eat his hat, so he did. And what you're seeing in this picture here is a blender. He did cheat a little bit. He took his hat and he blended it, chewed it up in a bit of a blender. He's just about to pour it into a glass to eat the thing. He didn't eat a whole lot, needless to say. His quote was, "This hat is not tasty." Now, this was done, of course, this is actually great PR for them. In fact, what they were doing was launching they're announcing a new rocket called Neutron, which is much bigger than their previous rockets. The Electron rocket they had before could only lift 500 pounds to low Earth orbit. This one will be able to lift 8 tons. They're targeting really all of these constellations of satellites that are going up for internet service. And they want a bigger piece of that pie, or in a hat in this case. So now that brings up a question. How many launches have there been since the last meeting, which was on February 6th? And as almost always, we end up finding that we have a great counterexample with with Starship. The prototype serial number 10 test, it didn't count. It doesn't count as a launch because it was only going up 6 miles, so it was suborbital. In fact, what you're looking at in this picture is a successful test, believe it or not, because the rocket went up, it came back down, it landed on the pad, and everything was just great, except something didn't go quite right. And then at 8 minutes after landing, it blew up and blew into the air. the Twitter feed was quite amusing on this. People saying things about, oh, it's the fastest reuse, second launch they've ever seen, so on. Anyway, yeah, so what people are doing now is voting on how many launches they think there have been. And it looks like, see, 13% of you said less than 5, 13% said 6. And then there were a bunch of votes here in the 8 to 12 range. Well, it turns out, in fact, this wasn't that busy of a period. I don't know how that, okay. Stop sharing results here. There were 7. And most of them were kind of routine kind of things, like there were several missions to take cargo to the International Space Station, one from the US and one from Russia. The one interesting piece of news was that there were a couple of launches from SpaceX of doing their batches of 60 satellites at a time for Starlink, the internet service. But what was interesting was what really made news was they failed to recover one of their boosters. Now, just a couple of years ago, everybody was amazed that they could launch rockets and they could bring the boosters and land them right back on the launching pad or on a barge. Now it makes the news when they don't do that. This actually does affect the economics for SpaceX. They only have 6 of the Falcon 9 boosters, so losing one starts to be significant. And one thing I will also highlight is that in their 20th Starlink mission, they did recover the booster successfully, and that was usage number 8 for it. So that matches their record so far. So they're doing quite well on the reuse. At this point, we'll end it. Maybe we'd have time for a couple of questions or comments, and then we'll move on to the main speaker.
I thought it was interesting that everybody guessed around the 7, but nobody actually guessed 7 launches.
Yeah. Okay, well, I guess if that's the case, we'll move on to our main speaker, Hugh Blair-Smith. He has a book and the topic of this lecture, which is Left Brains for the Right Stuff, talking about computer, space, and history. There's been a long history of course, computing being an important part of the space program. And he's just the guy to talk about it. He has an engineering and applied math degree from Harvard. He worked at what is now called MIT Draper Labs, which has been involved in a lot of advanced technology things over the years. He programmed the Apollo guidance computer and was involved in the space shuttle control software and even space station. He went off and worked on startups for a while and then returned to NASA. And now he's also working on a science fiction book. And of course, he gives these kinds of talks that we're about to hear. So, Hugh?